All right, here's a quick refresher on scientific notation. So if we have a number that's in our standard notation, we want it in scientific notation, we're going to take the significant digits, which are the ones that are kind of together where there's a bunch of zeros in a row. So like down here, these are all significant because here's where my zeros are in a row. So I'm going to take that 3 and the 8, and again, it always has to be between 1 and 9 point something, and times 10. And again, you don't count zeros, you count jumps. So the decimals down here, so there's 6, 7, 8, 9, and then 10 to get there. And again, remember positive 10 because this would be 3.8. You know, we really want to take 3.8 times 10 times 10 times 10 dot 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 to keep making this decimal go over and over and over and over and over to make that big number. So again, this is my answer to the first problem right there. Some calculators, you can type that in and hit enter. It might put it in scientific notation, or if you have a graphing calculator, you could type in 3.8 times 10 to the 10th, enter to check it, and it should give you this. All right, again, this next one, these are my significant digits. So again, 607 is way too big. We always have to have it between 1 and 9 point something. So I stick my decimal after the first digit all the time. And then again, the way you get zeros in math is either multiplying by 10 or dividing by 10. Now, this is 1, 2, 3, 4 jumps. So that would be a negative 4. And the reason it's negative 4 is because this is a tiny number, a microscopic, which negative exponents mean fractions or tiny decimals. Now again, remember what this really means is that you have 6.07, and you're not multiplying by 10 over and over because technically these 10s, negative exponents, mean they would be down here. And so really what would be happening is all of this would be dividing by, what is that, 10,000. So this would end up getting divided by 10,000, which would make it be a tiny number. Again, you should be able to type this on your calculator, hit enter, and it should give you this. All right, the next one, again, negative exponent means it's going to be a tiny number. So we're undoing it. So I have 2.8, and I'm going 4 jumps, 1, 2, 3, 4. All right, and so I add my zeros, so 1, 2, 3, 4, and again, it's a tiny decimal because again, negative exponents mean you're dividing by 10 over and over, so you take like 2.8 and then divide by 10, divide by 10, divide by 10, divide by 10. All right, so this would definitely make that smaller. Again, if you have a calculator, just type this thing in, check your answer, and see what you get. And again, typically, you know, we would erase all our work there, and just when we're done, we would just rewrite it. And so what would that be? What did I lose there? 2.8, oopsie, sorry. I would see if I can get my pen back. There we go. 2.8. So make sure that you actually erase the decimal when you're done. All right, the next one right here. So here's my answer for that one. This one, I want to make it times 10, times 10, times 10. This is going to make it go 5 jumps bigger. So again, 1, 2, 3, 4, 5. And again, you're not going to want to have a decimal there. So you should rewrite your answer 701, 1, 2, 3. So 701,000, and there's my answer. And again, you can check this on a calculator. Plus, it makes sense because if you take this times 10 times 10 times 10 times 10 times 10, obviously every time you make it 10, it's getting 10 times bigger all the time. So that would make sense. All right, I'm going to erase these top ones here for a second so we can have a little more space. All right, so on this bottom part, we're multiplying. And so I have this problem right here. And so again, numbers, this should remind you of multiplying like 3x to the negative 5th times, say, let me use a dot there, times 4x to the negative 8th. And so numbers are normal, you get 12x, and then where you're multiplying, the trick is you can add exponents. So negative 5, negative 8 is what? Negative 13, is that right? And then, of course, negative exponents mean to reciprocate, so we put the x to the 13th down there. The only thing is, in scientific notation, we actually like negative exponents because it makes it easier to type in journal articles. So 3 times 4 is 12. And then this and this, so numbers are normal, and this gives me 10 to the negative 5th. Negative 8 is a negative 13. Now, that would be lovely for scientific notation, except remember, this has to be between 1 and 9 point something, and so I can't have 12 here. So what I need to do is I'm going to make it 1.2, and by doing that, I stole a 10 from it. All right, so I'm taking a power of 10 away from this. That's how it got 10 times smaller. Okay, so I took a 10 out, it got 10 times smaller. Now, is everyone okay? This is really 10 to the first, right? And so then I can regroup these guys and get 1.2 times 10 to the negative 12. That's my final answer right there. Right, and then this bottom one down here, all right, so let's look at this one next. Let me change colors here. All right, so in this one, I divide like right there. So how many times does that go in there? Does that go in there? Is that goes in there twice? All right, so when I divide, I get 2 times 10 to the, and then again, divide these guys. You would subtract, like remember DS, you divide, you subtract because you're canceling. That ends up being 4. Again, some people like to flip these and move the 12 up as a positive. So they move this up as a positive exponent, this guy down as a negative exponent, and cancel. You can do that. But again, it should get bigger because 10 to the negative 12th is a really tiny decimal, and 10 to the negative 8th is actually a bigger number. So this should go in here more times. And so that's how you get that. The nice thing is this is already in scientific notation, so you're done.